How are you, everybody who is watching this fantastic session, which is session 4, and even this video. Before just I go to the session 4, how are you? Everybody who is watching this video, I really appreciate about your decisions to tune into Tanzania Online Advanced Secondary School in square bracket Olenjolai. So here I forgot M, so you have this one because this is the unique name. Okay, Olenjolai. Okay, Olenjolai. So just like this one. So I'm very happy to have you today. My name is Olenjolai Moko Tayai Losingo. Those are my phonemes or sequence of my phonemes sequentially. My first name is Olenjolai, second name is Moko, third name is Tayai, fourth name is Losingo. But simply, you can just summarize and call me Olenjolai. Okay, I'm from Tanzania, beautiful country. I love so much my country. If you're Tanzanian also, I really just convince you that to remember you're a citizen. You're citizens of Tanzania and you have responsibilities that you have to accomplish in our blessed country. I would like just also to remind you for the Tanzanians that remember, God lives in Tanzania, and for the international viewers, we'd like to welcome you into our beautiful country. Real that there are a lot of opportunities, and even if that also you can get a chance to do the tourisms in different actual unique sites or unique tourism sites. For example, the national park, the highest mountains in Africa. So wherever that you are watching me, I would like just to welcome you into Tanzania. Then you can take a time and then you come and enjoy. And Tanzanians are very good and calm people actually. Okay, so today I have very important information. Firstly, I would like to welcome you into Tanzania Online Advanced Secondary School in square bracket Olenjolai. And also I would like to welcome you to one of our YouTube channels that are called Tanzania Online A-Level Secondary School in square bracket Olenjolai. We are in Departments of Advanced Mathematics, and the subject is Advanced Mathematics. We are in Chapter 4 that called the Geometry 1. And also, we are dealing with the subtopic 1, which is called Rectangular Cartesian Coordinate. We have Session 4, we are in Session 4 that's titled as the perpendicular distance of a point to a line. Very important concept in coordinate geometry 1. There are so many questions which can be asked there, but we can use these concepts of the perpendicular distance, the perpendicular distance or the perpendicular shortest distance. That's some of the books they call this perpendicular shortest distance. Yeah, perpendicular or short, they call it sometimes the perpendicular or the shortest. Yes, the perpendicular shortest distance from a point to a line. So from a point to a line. So very important concept. But before I take you into today's session, I would like just to spend a few minutes to remind you about the vision in Tanzania Online Advanced Secondary School in square bracket Olenjolai. Simply, just in abbreviations, it's called the TOASO. 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 Okay, so these are abbreviations of an online institution. It is TOASO. Okay, Tanzania Online Advanced Secondary School in square bracket Olenjolai. Well, so we have an assignment that we've been given from God Himself, who have created us in His image and likeness. And the assignment is we have a responsibility to teach actually well-skilled students and even serious students in Tanzania, in African continents, but we'll be focusing in Tanzania because we're going to use the curriculum of United Republic of Tanzania and the syllabus of United Republic of Tanzania. However, that mathematics, the advanced mathematics is universal. This content might be helpful for the college students, for the institution, just university students. So we have an assignment to teach you who is watching this program right now, as condition, if and only if you are a serious student and you want to be competent in advanced mathematics. So we will teach you to extracting knowledge in advanced mathematics, for instance here, and then just first of all, to extracting useful knowledge and wisdom in advanced mathematics, and also we are going to teach you to extracting knowledge and wisdom from the Word of God, and we are going to teach you to combine these two knowledges, and we are going to teach you how you can solve real life problems. It's a matter of the mindset, it's not the matter of the age, it's not the matter of whether you are rich or you are wealthy or you are poor. Those are the negligible conditions from the vision that I'm telling you right now. So that the vision that we have in our heart, our main objective in Tanzania Online at the Advanced Secondary School, square bracket Olenjolai, is to see our continuing students and even our graduate students really solve real life problems and enjoy the beauty and their choice to study advanced mathematics and also to study advanced physics and advanced chemistry and basic applied mathematics. That the vision and that the main vision. We have so many specific objectives. One of our specific objectives will help you to pass your midterm test in advanced mathematics, for example, just to pass your terminal exams, to pass your annual exam, to pass your pre-mock exams, your mock exams. So we'll be helping you through teaching according to the syllabus of United Republic of Tanzania. Again, before even I go into too much details, I ask you to join. If you find that you are pleased right now or even later on when you finish this session, I think that I suggest you at the end of this session, you have to remember to subscribe so that you get the official notification once we add a new video. We have a vision to upload or to post more than 500. I don't think that it's more than 700 videos in this online, our YouTube channel that will be teaching you about advanced education by using the syllabus of United Republic of Tanzania. Okay, so now it's a moment that you have to take your reference textbook, your reference exercise book, your reference syllabus. Okay, because for myself as a teacher, I have my syllabus, and also I ask you that in case that you want this syllabus, you don't have it, you will use for learning advanced mathematics from 5 and from 6. It's very excellent. It's a unique book. It's a prerequisite for every Form 5 student, okay, and every Form 6 student. So you can order a copy of it when we have because we have you can order this book in online library of Tanzania Online Advanced Secondary School in square bracket Olenjolai, and we'll be selling to you with very affordable price. So in case that you want to order, just click the buttons written show more. You'll see the link which will send you to the video and know that how much we do sell the copy of this book, and we can also ship. We have again some other books of mathematics, Pure 1, Pure 2. We have Tranta, Pure Mathematics started by Tranta. We have also S-Chandi books. So we have so many books of advanced mathematics which can help you. You have also Concepts, Course of Statistics. So we have so many books that can help you to go through. So make sure that you go into the descriptions below so that you can get too much detail. So after giving you that piece of information, now it's a time to go. So remember that for advanced mathematics, the fundamental, the first session is stated as session 00, which is stated as general introduction in words, this abbreviation, general introductions of what? Advanced mathematics, okay, for what? Form 5 to Form 6. So this is an abbreviation, so you have to watch this video because I have declared the entire picture of advanced mathematics Form 5 and Form 6. Then we went for session 1, session 2, session 3. So session 1, we just talked to the general introductions of coordinate geometry 1. Session 2, we talked to you about gradients, okay, how you can deal with gradients, and then how you can deal with parallel lines, perpendicular lines, how you can find the gradients of them. And then in session 3 now, I taught you the concept that we call the distance formula. I taught you about distance formula, which I derived it, and we said that the distance between 2 points in the xy plane is given as x2 minus x1 square plus y2 minus y1 square. That's the distance that we have. Again, I told you about the angle, the concept that we call the angle between two lines. And I left your homework for you, the angle between two lines. So we said the angle between two lines, we determine this one by using arc of tangent, which we call the tan inverse. Tan inverse of what? Tan inverse, we say that the angle, the formula for the angle, is tan inverse gradient 1 minus gradients of the second line, means gradient of the first line, minus gradients of the second line, gradient of the second line, minus gradients of the first line. Then we have what? We have gradient of first line times brightness of second line plus 1. So this is the formula. This is the formula that will help us to find the angle between two lines. And we say that we have two types of angle. We have acute angle and also we have obtuse angle. So you've been dealing with Sisoti finding the acute angle, and I left the homework for you. And I didn't see, for many of you didn't submit in the. So we ended session 3 with homework 5, homework 3, which actually I gave you questions to prove the formula. Okay, the formula, there's a certain conditions that if that and that and that and that. So I believe that you did this simple question. I believe that you've gone through and you've shown, because it's demanding you to prove. So let us go to today's concept. We are in subtopic 1, titled as the rectangular Cartesian coordinate, and we are in session 4, the perpendicular distance of the point to a line. Say the perpendicular distance of a point to a line. This is how it has been written in the syllabus of advanced mathematics for advanced secondary education from 5 to form 6. Let me show you, because I want my students to prove. Okay, to prove what I'm telling them, because I don't want to lie with them. So this is the sentence. Let me bring close to the lens. This is the sentence. Compute the perpendicular distance of a point from a line. Okay, so that's why I said the perpendicular. I'm teaching about the perpendicular distance of a point to a line. So the perpendicular distance of a point to a line, we say that the perpendicular distance from a fixed point to a line is the shortest distance between a point, so shortest distance between a point and a straight line. So he said this is it's the shortest distance, first of all, between a point, a certain fixed point, and a straight line. All right? That's the meaning of perpendicular. So he said that in some of the books, they call it the shortest distance of a point to a line. So something it is called the shortest distance from a point to a line. It's the shortest distance from a point to a line. So geometrically, so when you continue, you can click that button of subscribe. Say subscribe. Why should you subscribe onto our YouTube channel called TANZANIA Online Advanced Secondary School in square bracket? It's for your benefit. That once we upload any new video, once we upload a new video in our YouTube channel, then the YouTube channel or the YouTube community has a responsibility to give you notification. Suppose that we have XY plane like this, and then here we have a certain straight line. Okay, certain straight line. This is the certain straight line, which is the equation. We can say that, actually you say that it is y is equal to mx plus c, or other format. We can write that this is ax plus bc, or plus what, plus bx, right? by, not b. So plus what, by Yeah, plus by plus c. This is another format we taught you during Form 4. By plus c is equal to 0. So these are we can define a straight lines like that. So we say that we can have a perpendicular distance, we can have a certain point somewhere else. Okay? You can have, let's say, this point should be perpendicular. Let's say here. Okay? So it means that this point here we have a point. And this point we call point P, which is x naught, comma, y naught. So this is the straight line. Okay, it has intercept. For example, it has the y-intercept, it has the x-intercept, it has the gradients you can determine. It has all the important information from the straight line. So then the concept that now we are dealing is, we can take a protractor and measure the 90 degree along this straight line, okay, in such a way that we have this. So you have this point of intersection. So here, remember that this line should be perpendicular to, so this is the line joining one point on the straight line with the point where we want to find its distance from what? A line. So remember the title, the perpendicular distance. So this is the perpendicular distance. What the means of perpendicular distance? It means that at one point you find that there's a right angle. So for example, here we have a right angle between this straight line. If you rotate it here anti-clockwise, we find we have a right angle. So that's why we call it the perpendicular distance of a point. Which point? This one. From what? Of what? Of a point to a line. From a point to a line. So this is what we call the perpendicular distance. So this is what we call the perpendicular distance. And in mathematics, we can call it, so we can label like this one. So this is an arrow. So this we call it D. So so this is figure T, this is figure 4.1. So whereby D is equal to what? Distance. So D, it's what we call the perpendicular distance. Perpendicular distance. So you see that why we call it perpendicular distance. But here also we have point of intersection between the straight line and the line joining point P and the straight lines. So this point of intersection, we can call it Q, which is x, y. So that is the shortest distance from here to here. And this is what we call the perpendicular distance. It can be in any directions, maybe at the top of the line or at the bottoms of the line. It depends to the situations that we have been given for the question. Okay, so there are different ways that you can find the perpendicular distance. Okay, you can find the perpendicular distance algebraically, and you can find the perpendicular distance by using the formula. So next few minutes, I'm going to give you an example that we are going to find the perpendicular distance between a point and a line by using what? By using the concept of perpendicular lines, gradients of the perpendicular lines, by using the concept of the gradient of the straight line, and also using the concept of what? Of finding equation of what? And using the concepts of what? Of distance formula. So stay tuned, and then that we are going to enjoy the beauty of this stuff. Okay, so let us continue about our concepts of the perpendicular distance from a point to a line. So how you've seen in this figure 4.1, you just have realized that we have a straight line and you have a point. So in most cases, in most problems that we are going to encounter, in this concept that we will be given possibly at a point and a line. And then you have to find the shortest distance, the shortest perpendicular distance between the point and the line. And you know that because we are mathematicians, so you have to use different tricks. So right now, you can do this concept, or you can solve this problem. For instance, that means we can find the perpendicular distance from a point, perpendicular distance of a point to a line by using two concepts. The first concept, we might use just algebraically, and the second concept, we might use just the formula. So we have the perpendicular distance of a point of a pointy to a line. So you have two ways. So you say that ways of finding the perpendicular distance. The perpendicular distance of what? Of a line to a point. So in advanced mathematics, according to mathematicians and according to the coordinate geometry, how many ways do you have to find the distance at the perpendicular distance between the pointy and the straight line? That's a very interesting question. You can pause the video and then try in the rough paper to write how many ways you can predict, even if that is the new concept for you. And then so you press the play buttons, you continue on enjoying the beauty of advanced mathematics. Well, so we say that in advanced mathematics, possibly that maybe in advanced pure mathematics, okay, because this is pure mathematics, there are two ways of finding the perpendicular. If you find that I'm teaching you quickly, you can pause the video or you can revise this video several times. Perpendicular distance of a pointy to a line, of pointy to a line. So these two is the first one. We say that we can find algebraically. And simply that the main concept here, we combine three concepts. First of all, we use the concepts of the gradient. We use the concepts of perpendicular lines. We use the concepts of distance formula. So I will explain to you and I will give you examples soon. The second method, by using what means you can use by using the formula. Okay, so we can find by using what? By using the formula that we are going to derive the formula of the perpendicular distance. Okay, of what? Of a point to a line. So this is the concept that you have to remember. We have to use it effectively. Okay, so we say there are two ways. The first one, we can find it algebraically. So that's the first method, which I'm going to teach you and give you examples soon. And it's very interesting. Okay, so let us start with the first method. So finding, it means this is called method 1. Say method 1. So method 1, we say that finding the perpendicular distance of 40 of a point to a line. But okay, algebraically. Say algebraically. By using the algebraically. Okay? So let us learn this first method, and then I will teach you the second method, and then you'll enjoy the beauty of advanced mathematics, especially coordinate geometry 1. So you're Tanzanians, and then you have to enjoy it, and you have to think it at how you can apply this information to solve real life problems. Okay, so with this concept, we say that if the equation, okay, if the point and the equation of the straight line are given, then the perpendicular distance of a point to a line can be found by using or by following, these steps. The first step, we say that find what? First step, find the slope or gradient of what? Of given equation of the straight line. At the first step. The second step, after finding the slope of the given equation. The second point now, which we ask you that to do, we say that find or compute, find the perpendicular or find the perpendicular gradient of a line from the point to the point of intersection. Every step I will show you right now soon, and you'll enjoy it. Okay, so to the point of intersection between two lines. I will show you, or I'll do example, follow all of this system. Then after finding the perpendicular gradient of a line from what? From the point to the point of intersections between two lines, the next step now, we have to find the equation. So the good thing is you have to be careful in this method, because we are going to derive the formula of finding the perpendicular distance of a point to a line by following these steps. So that's why I'm teaching you clearly. We'll do example and using these concepts to solve the problems, but you will derive the formula of finding the shortest distance or the perpendicular distance of a point to a line by following these steps that I'm writing. The first step, second step, third step, and etc. etc. So find what? So find the equation of what? Of the line, of the new line, or of the line joining the point of intersection, and the given point. I will teach you also this, the given what? Point at the next step. So now you have what? You have equations of the two lines. The given line and the line between the point of intersections, or it means the lines at the perpendicular and what at foot of perpendicular and what and the point. Afterwards, so you have two equations now. We got the first step. The first step, we say now solve for the two equations. So we say that solve for the two equations. It means for the two equations means find the point of what? Of intersection. The point of intersection between what? Between two lines. That's the concept that you have to find. Solve for the two equations, or find the point of intersection between the two lines. Then now we have the point of intersection. We know the coordinates of the point of intersection, which in mathematics we call the foot of perpendicular, and we know also the point where we are finding its distance from the line. So you have 2 points now. And then our aims, we want to know, because suppose that this is the foot of perpendicular, the point of intersection, and then this is the point where we are finding its distance. So it means that now we know the coordinates of this foot of perpendicular, and we know the coordinates of this given point. So you know what you have to do? We have to use the distance formula to find the distance between them. That will be the perpendicular distance of a point to a line. So the fifth step now, say that use the distance formula. Use the distance formula to find the distance between what, which is the shortest distance between given point, the given point, and the point of, so the point of foot of perpendicular. And then that is the distance that you'll be looking for, foot of perpendicular. My dear students, I want to tell you that I've been teaching this topic for more than 6 years physically. But the good news which I want to tell you that in all my 6 years of analogy, 5 years of teaching this topic, I've never taught them this concept in the simplified way like the way I'm teaching right now. Even myself, when I learned, nobody who have explained me these steps. What actually that I was finding the men are not seeing, you find that you have been given an example and it has been solved. So you know that. So it depends about your concentrations by that time. But having these steps will help you. And really, it's a great challenge to derive the formula of finding the perpendicular distance of a point to a line, or of a point from what, a line. Because you got the perpendicular distance of a point to a line. So it's a challenge. But if you have these steps, my dear students, I want to tell you that everything is going to be smooth. Not simple, smooth. Say smooth. Do you love advanced mathematics? Tell me in the comment sections, please. So while you are thinking about those systems, let me introduce to you example 6, which is a problem or it's a question about this concept that I'm teaching you, and we have to solve it by following these steps. Okay? So let me write the questions. It's just as simple, it's not just like a great or it's maybe wonderful question. It's a very interesting question. So you find. So let us go. Example 6. I will show you, I will explain to you, so this example I will explain these steps. So this is the example 6, ladies and gentlemen. The question asks you that, find the distance from point P, which is 5,6 to the line. To the line 3x plus 4y, then this is equal to what? 12. That's the questions that we have in play. So you have to find what? Find the distance from that point P, which is 5,6 to this straight line. So you see, we'll be given a point, we'll be given us a straight line. Okay? So so we'll be following some steps in order to solve this problem. Once you be given this problem, you can use either method 1 or method 2. But method 2 is the one that preferred by many examiners. They really want to see you that you are writing the general formula of finding the perpendicular distance of a point to a line. Right? That's the preference, that's the choice, rather than this algebraical method. So let us solve. Okay, don't worry about that. Let us solve. So solution. We'll be following some steps on solving it. The first step, you can sketch the line and point where in x, y plane. okay, in XY plane. So just a sketch. So to sketch it, we say that you may also use the concepts of x-intercept and y-intercept just to sketch that line quickly and also to have those points. Okay, so let me sketch. So this is y-axis and this is x-axis. So in case of the point, we have 5,6. So 5,6, this is 0, okay? So it's along the positive side. So suppose that this is 1, this is 2, this is 3, this is 4, this is 5. Okay? Then along this side, we are going to have, this is, because of the space, this is 2, this is 4, okay, this is 4, and this is 6. Okay, I can also prolong on the negative side. So I've just decided to say 1, 2, 3, 4, 5, and then the next one here will be 6. Then we come on this side, we have -1 at the same interval, -2, -3, -4. Here I have 2, I have 4, so it means I have 1 in between of 2, I have 6, possible that I have 8 somewhere. Then this is -2, -4, then -6, possible that -8. So the point here is 5,6. So where is 5? So this is 5. So then I can just have the point like this one. So here it is. For you, you can draw. But for me, I'm going just to sketch to give you the general idea. So this is our point P, where we have 5,6. Then we have this line. To find the x-intercept, y is equal to 0. So the x-intercept, it means this is 3x is equal to 12. Make x the subject, it will be 4. So our x-intercept is here at this point. So it will be 4. Find the y-intercept. To find y-intercept, we plug x is equal to 0. So 4y is equal to 12. So 12 over 4 is equal to 3. Okay, it's equal to 3. So this is the point. This is 3. So our straight line will be passing through these 2 points. But remember that I'm sketching. Okay? So this is our straight line. And our straight line here, it is what? 3x plus 4y is equal to 12. So then we are looking for the perpendicular distance. Suppose that this is our perpendicular distance at this point. So our perpendicular distance is at right angle like this. Here we have a point of intersection. Suppose this point of intersection, we call it is Q, X, y. So we have P, we have Q. So this is the point of intersection between this line from the point to the line and also with this what is straight line. So here we don't know first of all, we can find the gradients of this line 1. We can also find because this line perpendicular to this line, we can use the formula of the perpendicular lines to find the gradient of this line. Then we can also use that gradient with this point, with this arbitrary point of x, y, to find the equation of line PQ. And then we can solve simultaneously. Okay? This equation 1, the given equation, and the new equation that we found. And after we solve simultaneously, we get this coordinates of 40 x of point Q, which is x, y. Then we can use the distance formula to find the distance between P and Q, and we are done. Okay? I believe you enjoyed this little introduction. So this is figure 4. This is figure 4.2. Okay, figure 4.2. So if you join me right now, you're only welcome. I'm teaching you coordinate geometry 1 for advanced secondary students who are studying Form 5 in the either of the 4 combinations in Tanzania. One of the combination is what? Is PCM, this material for the PCM, also for the PGM, also for the EGM student, and also for the PMC students. But for the international students, possibly that you are learning these subjects in high school. Okay. So this is the figure right now. So you go for the second step. The second step, we just go to the first step of the method 1. Let us find, ladies and gentlemen, the slope of what? Of given equation. Okay? What is our given equation? Our given equation is 3x plus 4y. This is equal to 12. That's our given equation. So to find the gradients, we have to make y the subject. To make y the subject, you have to minus by 3x to both sides. So 4y is equal to 12 minus 3x. So then 3x minus 3x is equal to 0. Here we have 4y is equal to 12 minus 3x. So then we have 4y is equal to negative 3x plus 12. So then we divide by 4. We divide this side by 4 and this side by 4. Right? So you have y is equal to negative 3 over 4x plus 3. So this is, let's say, equation 2. Because this is equation 1. Let this as equation 1. So after having this equation 2, we say, because we are looking for the gradients, we say that compare equation 2 with what is the standard equation of the straight line, which is y is equal to mx plus c. Gradient, y-intercept, right? So if you compare, so suppose that this is equation 3. So if you compare, you find that the gradient or the slope is equal to negative 3 over 4. The y-intercept is equal to 3. So suppose that because this is the first equation, we call it the gradients of the first line. Okay? The second step, if you do remember that, go back to the second step of the method 1 of finding the perpendicular distance algebraically, or of finding the perpendicular distance of a point to a line algebraically. So the second step now, because these two lines like PQ and these lines of 3x plus 4y is equal to 12 are perpendicular. So if they are perpendicular, the gradients of line PQ means that the gradients of line PQ means that if I the product of the gradient of the first line of 3x plus 4y is equal to 12, and the gradients of the PQ is equal to negative 1 for the perpendicular, or for the perpendicularity. Okay, so because I know that you're still copying, let me clean this part. Remember to subscribe. We are going to have more than 700 videos in this channel for teaching advanced mathematics, basic applied mathematics, advanced chemistry, advanced physics, Form 5 and Form 6. So you have to make sure to subscribe, and we are adding a new video in our channel every day. So you get notifications once we add any new video. So you go for the third step. The third step, because remember that here, this is the first step, so it's a one. This is the it's a new step that I didn't mention in the method 1 because it's optional. Sketching is optional. Just it helps you to see how the steps are, or what steps you have to follow. Okay, so he said that let us now find the slope of what? Of equation. Okay, of equation what? The slope of the equation PQ. Okay, of the equation, the slope of the line, excuse me. It's not the equation, excuse me. The slope of the line, of the straight line, PQ. Okay, so we say that the slope of the PQ, because it means that, we say that the line, we say that 3x plus 4y is equal to 12. This is perpendicular to 0 to the line PQ. Just like that one. So if they are perpendicular, we say that now the slope of 40 of PQ, we can let this one, we can let it to be slope 2. So it means if you take gradient of the first line, you multiply with the gradient of the second line, the answer always is equal to -1, as I taught you in the second session of 40 of coordinate geometry 1. So you have gradients of 40 of the first line, so we can make M2 the subject. So to make it M2 the subject, this is equal to -1 over M1. Keep these concepts of perpendicular, keep this concept of the products of gradients of the perpendicular lines, because we are going to use it in coordinate geometry 1. We are going to use this concept sometimes in applications of what? Applications of in applications of differentiations, especially finding the equation of the tangent line and the normal line. But also we need this concept in coordinate geometry 2, okay, in finding the equations of the tangent and the normal line to the parabola, to the ellipse, and also to the hyperbola. So make sure that you remember this concept. So gradient of the second line is equal to -1 over gradient 1, which is -3 over 4. So simply, this is -1 over -3 over 4. So to find the second, or M2, this is equal to what? So if you do the multiplication, that is equal to what? So it's equal to -1 over 1 multiplied by 4 over 3 over, yes, this one. So the answer is equal to what? So the answer is equal to -1 times 4, it is -4 over 1 times -3 is equal to -3. So the answer is equal to 4 over 3. That's the gradient of the second line. So we say the gradient of the second line, which is equal to the gradients of the line PQ, this is equal to what? Is equal to 4 over 3. Refer the steps that I told you that you have to follow on solving this problem algebraically. So I need to leave this place or this step. So the third step on those steps that I have written is what? After finding the gradient, now we can find the equation of the line joining what? The foot of perpendicular and what? And the given point. That's the step right now. We know now the gradients of the line PQ. So the next step, we have to find the equations of the line PQ in order to solve it simultaneously with the given equation. Okay? Okay, so if that's the case, now we have the gradient, so we go for the first step. The first step, we say that we've been given that point, or we've been given this gradient. So the first step, we have to say that, which is the third step for the method, we have to find the what? To find the equation of the line PQ. So to find the equation of the line PQ, what piece of information do we have? First of all, we know the coordinates of point P, so we need the coordinates of point P, big U is 5,6, but we have also arbitrary point, which is Q, which contains x, y, but also we have gradient 2, which is equal to 4 over 3. Once we have these three pieces of information, we can find the equation of the straight line. Good news. So to find the equation of the straight line right now, you know what happens. So we have to say that you have to recall, we say gradient is equal to y2 minus y1 over x2 minus what? x1. Suppose that this is x2, y2, x1, y1. So gradient, so it means that for gradient 2, it is 4 over 3 if you substitute. And then so you have y minus 6. And here we have x minus 5. So next we have to simplify and cross multiplication. Cross multiplications, we have 3y minus 6. This is equal to 4x minus 5. So then this will make 3y minus what? Minus 18. This is equal to what? 4x plus 20. Right? So then we say that, okay, fine. So plus 20. So we can simplify further. We have 3y minus 4x, then minus 18 minus 20 is equal to 0, right? So we are going to have 3y minus 4x, then this will make your t negative 38 is equal to 0. So let me check if you are right. Again, 3y minus 18, then 4x minus 20. I made a mistake here. This is minus 20. 4 times negative 5 is negative 20. So if that's the case, here we are going to have plus. Okay? So plus, so the answer here means to be what? 3y minus 4x, and here it will be plus 2. Plus 2. So 3y minus what? Yes, 3y minus 4x plus 2 is equal, yeah, plus 2. Plus 2. Or can introduce just negative. You can have negative 3y, then positive 4x, and then you have negative 2 is equal to 0. No, there's no need to say it's equal to 0 right now. There's no need to do that. So it means that he simply said that, so simply, listen, so simply, I think that from this state, what we have to say, but depends, okay? So you can say that this is 3y minus 18, okay? Or we say that, let's say that minus 4x, this is equal to negative 20 plus 18. So then now we find 3y minus 4x is equal to what? Negative 2. To rearrange it, maybe probably for negative 4x plus 3y is equal to negative 2. So it can be this form or this form. So this is equation what? I think that this will be equation 4, if I'm not mistaken. So then now we have equation 4, which is this one, and we have also this one. So you go forward to the first step. Now, we know the equation of the line PQ, and we know the equation of the given straight line. The next step now, which we have to follow is, which the fifth step. The fifth step that now we have to follow to solve this problem, okay? The fifth step. Now, we can solve this given equation with this given equation, or with this equation that we found simultaneously, to get the point of intersection, which we call the foot of perpendicular. So once we get this point of intersection, then we go to the last step of the method 1, which is using the distance formula. So the fifth step, we say that now we can find what? We cannot solve equation 1 and the equation 2. You have to listen carefully, because in deriving the perpendicular shortest distance, it means in deriving the perpendicular distance of a point to a line, we are going to follow these steps. If you understand this step, that's why I'm teaching you consistently about this method 1. Because if you understand this one, because in some of the questions, for example, in paper 1, you can find the question of the 5 marks that derive, given that this is the equation of the straight lines, and there's a point, given that this is the equation of the straight lines and the point, which is this one, so derive the formula of finding the perpendicular distance of a point to a line. So the question, so you can be asked to derive, so you have to listen carefully, which will be the next session. Okay, so the fifth step is solve equation 1 and 2 simultaneously. Okay, simultaneously. How do we solve? Good. We have 3x plus what? That's equation 1 plus 4y is equal to what? 12. Then you have equation 2. This is negative 4x. Then what? Plus what? Plus 3y is equal to what? Is equal to negative 2. There are how many methods to solve simultaneous equation? Elimination method, substitution method, graphical method, right? and using scientific calculator because you're an advanced student. And the good news also, we have our online library, which we call the online library of Tanzania, or Tanzania Online, Tanzania Online Advanced Secondary School, in square bracket OLENJOLAIM. So in this library, we have very interesting material. The first reference material that you need as our excellent student is the syllabus. This syllabus is called Advanced Mathematics for Advanced Secondary Education from 60. This is the message for the national students who are studying in Tanzania by using the educational system of Tanzania. If you are watching this video from Kenya or from UK, United Kingdoms, or from United States of America, please make sure that you go to the local shop and look the syllabus for advanced mathematics of your country, because you can find there's a little bit difference with our syllabus, but you can use the context because mathematics is universal. So what you are learning is, now we are learning about perpendicular distance, okay? Perpendicular distance of a point to a line. Even students who are studying in China, they are learning also this concept in high school or maybe in college stage. So this is the one of the equipment. But the second equipment is we have the textbook, Pure One, right? This is the reference and recommended book according to the curriculums of United Republic of Tanzania, and even according to the world, we say that according to UNESCO, okay? It means that this is the recommended pure mathematics book for the Form 5 and Form 6. This is Pure 1. We have also Pure 2. We have also Pure Mathematics by Cantor. We have also Understanding Mathematics, your course of statistics. So just go to the descriptions, click the button Show More to see the link that will take you to the video to know how much does this cost. Okay? Again, we want to equip our students with questions and answers books for them to understand and test their understanding in advanced mathematics. So you have, so in Tanzania, we have 2 advanced mathematics certificate paper, right? For high school, we have advanced mathematics paper 1, which is, and you also have advanced mathematics paper 2. So this is the questions and the answer. It's a book which comprises questions and solutions of the past papers of Tanzania from 2003 to 2018. Okay, again, so we have another weapons, which is number 4, and then we have advanced mathematics review, right? Advanced mathematics review, and then this book also contains questions and solutions of 40 of advanced mathematics paper 2, right? From 2003 to 2018. So you can order all of this book and more than this, because these are just demonstration books. In the comment section there, we are selling with the very minimum price, affordable price. We can ship in all 31 regions. So you have just to make sure that you buy the entire package in order to equip your students, in order to enjoy, to minimize their shipping cost for a single item. Again, we have, as I said, or as I mentioned, we have again another important tool which we need in our learning of advanced mathematics and advanced physics, and even other advanced courses. And this important tool is a scientific calculator. And the good news also, in our library, we have so many original scientific calculators, which actually that we need to offer to our students. Okay? So you see, for instance, there you need to have a scientific calculator. So possibly you lost your scientific calculator, or you don't have it, any of them. Don't worry. Don't worry. You can get original scientific calculator from online online library of Tanzania Online Advanced Secondary School, the square bracket OLENJOLAIM. So just click the button Show More, and then so you see the link of the video, and you can order original scientific calculator. This is Casio function 991. I'm using myself as a teacher, and I owned this scientific calculator 3 years ago, and does not have any problems, and is doing great things. It's doing great computations. Really, it is accompanying me in my daily learning of the beautiful subject that is called engineering, queen of engineering, that is advanced mathematics, right? So make sure you have it. So for this case, we can, as I say, that you can use basically 4 methods to solve this multiplication equation. The quick method is by using the scientific calculator. You feed those equations, and the scientific calculator think on your behalf, and then finding the value of y and value of x. But because I want to prepare you to understand the derivations of the perpendicular distance, okay, of perpendicular distance, okay, of a 20 to a line. So I'm going to solve that equation by using elimination method, because when we'll be deriving also, we won't use the scientific calculator because we are going to have only variables. So I'll be using also in derivation the method of 40. I'll solve this continuous equation, which it contains the letters. I'll be solving them by using what? Elimination method. Right? If you understood, tell me in the comment section if you've understood this clear concept. So then we said that let us solve by elimination method. So elimination method, we learned this method when we were in Form 2 or Class 10. So the elimination method, we have 3x plus 4y, and then c is equal to 12. So we have to inspect the given or the two given equations that we have to solve them simultaneously. And when we examine, we have to check and see that how we can eliminate one variable, because we have two variables there, x and y. So to eliminate the simplest variable to eliminate here is x. So how can you eliminate? We have to make sure that we think a number that we have to multiply on the left hand side of each equation and right hand side, so that to have the equal opposite values of x. So you know what happens? So in order to make these values to be there, to have the same value except the sign that here is positive, here it is negative, then I have to multiply this equation 1 by 4, and I have to multiply this equation 2 by what? By 3. So once I do this one, I take 4 times 3 is equal to what? Is equal to 12x, and then 4 times 4 is equal to 16y. This is equal to what? 12 times 4 is equal to 48. Then I take 3 times negative 4, which is negative 12x. Then 3 times 3y, this is 9y, and this is negative 6. So you know the next step? The next step, I have to add them. To add them, I have to take 12x plus negative 12x. This will make what? 0, right? So it means that suppose that maybe I can have like this one. So here I have 0. Plus what? 16y plus 9y, this is 25y. This is equal to what? 48 minus 6. 48 minus 6, this is equal to 42. So simply now, we have 25y is equal to 42. So we divide by 25 to find the value of y, divide by 25. Okay? So then our y component, or our y-axis component, is what? Is 42 over 25. So y is equal to 42 over 25. You can express also in decimal. So it will be 1.what? So 42. So I think that if you take now in decimal place 42, so you can use your scientific calculator, over what? Over 25. Nice. Okay, it's 1.68. So this is 1.68 in decimal, in fraction form, in decimal form. Okay, so afterward we say that, okay, so this is, let's say, okay, yeah, okay, fine. Okay, so let us go for the 60th step. The 60th step now, find value of 40 of x. Okay, of x, okay, by, okay, from what? From any equation, let's say from what? From equation 1. Equation 1, it was 3x plus what? So we say when y is equal to 1.68, or is equal to 42 over 25. So 3x plus what? Plus 4y is equal to 12. So then we say that we have 3x plus what? 4. And then we say we have 1.68. We have 1.68. This is equal to what? Is equal to 12. Right? So then we have 3x. Then there we have just to use the scientific calculator quickly, just to do these computations. That's why we have it. In order for it to simplify our work. 4 times 1.68. Okay. This is equal, okay, so it will be 60.72 is equal to 12. So this is 3x is equal to 12 minus 60.72. So 3x is equal to what? 12 minus response. Then we have 5.28. So we divide by 3, we divide by 3. So x is equal to what? So this one over 3. So the answer is 1.76. If expressed in fraction, this will be is equal to 44 over 40 over 25. So you have option. You can put your response in terms of what? Fractions or in decimal. So these are the coordinates of 20Q. So 20Q now, right? So 20Q, it has two coordinates. The x coordinate is 1.76. The y coordinate is 1.68, right? 1.68. Okay, 1.68. This is the coordinates of 40 of Q. So we have now the coordinates of Q and coordinate of P. Next, the seventh step is what? We are using what? Distance formula to find what? The distance between those two points. Interesting. Interesting. My dear students, we are finding what? Perpendicular distance of a point to a line. Okay? So then we say that, okay, we have PQ. Okay? So we have PQ. Then the next step, we say that, okay, so we say this is the seventh step. The seventh step. Okay, the seventh step. We say that now, let us find what? The perpendicular distance. The perpendicular distance, okay, of what? Perpendicular distance of a point. A point what? A point P 5,6 to what? To a line. To a line what? To a line 3x plus 4y is equal to 12. By using what? For this case, you say by using distance formula. Say distance formula. So by using distance formula. Okay. So to do this, we say that, okay, to do this, to achieve this one, we say that from, we have to recall what the formula of distance formula. D is equal to square root of x2 minus x1 square plus y2 minus y1, y2 minus y1 square. My dear student, the steps that I'm following on solve this problem will be follow all of these steps in derivation, in one of the technique of deriving the formula, the general formula of finding the perpendicular distance of a point to a line. Okay, so now we can let this to be possibly x1 and this to be x1, y1, and then this is x2, y2. So we say that the distance, which is the perpendicular distance of a point P 5,6 into a line 3x plus 4y is equal to 12. This is equal to what? This is equal to the square root of what? Of 5. Okay, we say that this is x2, y2, x1, y1. So x1, it is what? 1.76 minus what? 5 square plus y2. Y2 it is what? 1.68 minus what? Minus 60 square. Okay? You can pause the video at maybe you can pause the video in either steps and then you try yourself on the rough paper, then you play or you press the play buttons to check the solutions whether you are right or you are not right. So now to find this distance, you have to use your scientific calculator in order to simplify your life. You can also consider this as the x2, y2, and the x1, y1. I think you know that. So here we say that we have 1.76, and then we minus with 5, then open close bracket. Then we have what? 1.68 minus 6, then this one, square. Okay, square. Then we find the square root. The answer is 5.4 units because we don't have what? This centimeter. We don't know whether the distance is in centimeter. We don't know which unit it is. So centimeter or meter or inches, we don't know. So in mathematics, we just call it units. If it could be area, we could write that units square. So therefore, ladies and gentlemen, we say that, let me write the final response. The perpendicular distance of 20 P P, which is 5,6, to a line, which line? To a line 3x plus 4y is equal to 12, is equal to 12, okay, is what? 5.4 units. That's the final response. And congratulations for understanding how I can find the perpendicular distance of a pointing to a line. Okay, so I think that I have given you so many important information. Now it's a time for you. If you didn't understand any point, please ask your questions in the comment section. And then I ask you that review this video several times as well as you can, because that's the advantage of the digital technology. And then now I want to give you a questions that will test your understanding, whether you've understood my session 4 of coordinate geometry 1 in the subtopic of rectangular Cartesian coordinate. And the session is titled as what the perpendicular distance of a point to a line. So let me now give you the homework for you try, and then I will invite you in session 5 when I will derive now the perpendicular distance, okay, or perpendicular distance of a point to a line. And then we'll be solving questions. So don't worry about that. So then I have a question, right? I have a question, which will be the homework. What will be the homework? Okay, so this will be example 7. First of all, this is homework. Homework what? 4. And this is example 6. I want just to give you a simple example, so you may know it yourself and send your solutions in the comment section. Find the distance. Find the distance from a point, and this point is -3, okay, comma -1 to a line y is equal to 2x plus 6. 2x plus 6. 2x plus 6. Okay? And then this one, hint. Don't use the general formula of what? Of perpendicular distance from perpendicular distance of what? Of a point to a line. But solve it algebraically. So solve by following the 7 steps that I taught you to follow. So this is the end of our beautiful session 4. I believe that you have enjoyed. You have got very important materials that you are going to use them, and they are waiting you in combining this knowledge, extracting knowledge here, and combine the knowledge of the Word of God from the departments of the kingdoms of heaven in order to solve real life. So this is the end of session 4. I invite you in session 5, where that I will keep on teaching you the concepts of a perpendicular distance of a point to a line. So don't miss, please don't miss session 5. It's on the way. And then I thank God who have created me in his own image and likeness and sent me as his, just as the embassy or as a citizen of the kingdoms of heavens. And the beauty teaching in me, I am a teaching, and teaching is me. And teaching in me is just like how God has built the flying character or the flying capability to birds. because birds, they don't attend the flying schools, but you find that they are flying in the air and in the atmosphere, and you see them, and they are very interesting actually. So similarly to me, that's how the teaching it is. It's been built in my heart. It's a work of my heart. I love it so much, and that's why that I bless the Lord through teaching you. So this is the end. I have just a few things to remind you quickly. The first thing for you to register yourself in our YouTube channel, make sure that you have an official email, whether Gmail or Yahoo mail. And then make sure that you sign in and you click the buttons of subscribe. And then that once you click that buttons of subscribe, then now you can also click the bell, the buttons of bell, and then you can choose the options of all. So from there, it's just a week of 30 seconds. You are done. Once we add any video, because I told you that we have a vision to have more than 5 high definition video that will be teaching the pure educations of advanced mathematics, Form 5 and Form 6, advanced physics, Form 5 and Form 6, advanced chemistry, Form 5 and Form 6, and basic applied mathematics, Form 5 and Form 6. So it means that we'll be adding a video, at least one video every day until we accomplish this project, which is actually it's a long-term project. But again, another thing, I would like to invite you to welcome you to offer your free willing thanksgivings in order to support the running cost. It's really expensive to prepare a video and publish it publicly to you. It's really expensive. There's so many costs there which I have to encounter myself as just as a dreamer, or just as a the founder of this program. So we invite you to offer your free willing thanksgivings to God, because if we could charge you, you could pay a lot of money to get these contents. But God said that no, I have to offer the free willings, and this is a gift for the Tanzanians. Okay, so you can do that. You can send your free willing thanksgiving of any amount. So this telephone number 0759745331. Confirmation name is Olenjolai Tanyai. In case that you want to do the bond transaction, just go to the descriptions below. In the show more buttons, you will see the bank account and even the bank name. So it means that your offering will be helping us to pay the running cost for this project to keep, in order to make so many lectures and so many videos of so many sessions to be in air to benefit present and future generations. I ask you also, because our aim, our main objective, our great desire, our strong desire to see this message has spread across the entire country of Tanzania in all the 31 regions. So please share this good news. Check the icons of share there of this video, and then share through WhatsApp, through Instagram, through different social media. Share these contents with your classmate, with your schoolmate, with your O-level schoolmates, with your young brothers, young sisters. Tell them now the light of God in advanced educations is around the corner. So that's the good news. May God bless you. I'm always praying for all my online students, because I know that God loves you so much, and I have an assignment as your teacher to pray for you. I ask you also, really, this is a great and fantastic work. For example, in this school, I'm teaching you almost 10 subjects alone, myself, which actually needed 10 physical teachers to stand in their position for 2 years. But through God's grace, everything is possible. Even the running course that I told you, that my God is greater than the running cost for this program. This program belongs to Him, and it is giving Him glory and the power and the honor forever and ever. So the point that I want to make is, I ask you to pray for me. Pray for the online students. Pray for this project. Pray for all the equipments, multimedia equipments that I'm using. Pray for everything to be okay, for my health, for my everything. And may God bless you until we meet. I invite you in session 5, where that I'll teach you the derivation of 40 perpendicular distance of a point to a line. May God bless you abundantly. I'm waiting you to take you from one point to another point in the session 5. May God bless and keep you until I meet you.